And welcome, YouTube. We're looking at the most filaments we've ever covered on the channel in over 5 years of daily space weather videos. Likelihood of coronal mass ejections as high as it gets. Likelihood of major solar flares also incredibly high. Pardon the lack of content. Smash staff and I have been feeling a little bit less than optimally. So let's get back to a bunch of data. It should help your understanding of things like heliophysics. So this is ionized helium and a massive number of filaments. So just to draw some attention to some of these filaments here, you can see this one up here looking quite unstable. This one down here, very, very dense. This one over here, huge filaments all around the Earth-facing portion of the solar disk, and a massive uptick in solar activity in general. The radio flux now up to 161 solar flux units, a couple years early. There is the 1-year chart from solon.info. So looking at the Space Weather Enthusiast dashboard, we're going to scroll down. By the way, there is a chance for continued geomagnetic unrest. We're in a state of geomagnetic unrest right now, and expecting some geomagnetic storms, or at least NOAA is tomorrow. That's from a possible glancing blow from a coronal mass ejection. Most space weather forecasters thinking that is going to miss Earth to the east. So just to show you where we are in terms of radio flux progression, 161 solar flux units is way up here, folks. Way up here. So approaching levels here that were only reached at the peak of solar cycle 24. We've also got some migrating sunspot umbrae. That's yesterday and today's imagery in intensitygram from the SDO. See some umbral migration happening here. Fast movers showing up there in the northern hemisphere. Likelihood of solar flares very, very high from this sunspot, and this sunspot. More on that momentarily. So we got some great footage for you here today. Geospace magnetosphere movie not playing. And there we go, we were able to refresh that. Currently in a period of geomagnetic unrest. A minor uptick in the solar wind speed, and a little change in the magnetic field orientation, the vertical component. Getting into negative territory, we'll get to it. First, ground magnetic perturbations. Earth's magnetic moment from the ground. We showed you Earth's magnetic moment from space. Here it is from the ground. You see that little uptick there? Aurora are likely in those red areas. Let's see some magnetic pulses out of the center of the Indian Ocean as well. So there's your planetary K index at 4 geomagnetic unrest conditions. And it's caused by this uptick in the solar wind speed, making it up to nearly 500 kilometers per second. And if geomagnetic unrest will continue, it's all whether or not we see a strong negative BZ. So this red line here, that's the BZ, the vertical component of the magnetic field. Keep in mind this is measured at Lagrangian point 1, a million miles from Earth, in between Earth and Sun. There are your GOES magnetometers over the past 3 days. And Earth remains in a North Pole current sheet shown here in green. Here's our line of sight field plot as the solar polar field migration continues in a rather slow fashion here in solar cycle 25. We've got some coronal holes in the Earth-facing portion of the solar disk. They're North Pole oriented. How about a visual? 193 angstroms is a great wavelength. I would note, North Solar Polar Field. still pretty constrained at the north heliographic region. South one, not so much. Likelihood of major solar flares very high. Don't be surprised to see X-class flares, M-class flares, etc. Look at the percentage probability here, especially from sunspot 3053, 3055, and 3056. Most likely places to see major flares are those sunspots. One of the ways we see solar flares affecting things is through radio blackouts. So you can see we're at such a high level of X-ray output in general that we're just seeing roving brownouts here, mainly around the equator at noon, as the D region of the ionosphere gets modulated by those incoming X-ray photons. Some radio signals end up in space instead of refracted back down to their target on Earth. If you want to look at that yourself, you can monitor it at the Space Weather Prediction Center. Remember, folks, there's no warning for a solar flare. Don't get solar flares and coronal mass ejections confused. Solar flares are photons. Coronal mass ejections are primarily protons. So let's take a look at sunspots here in 1700 angstroms. And how about a little closer look? This is the past 24 hours. You can see that umbral migration we talked about earlier in this sunspot up here. Next, we're going to move into solar flares and energetic particles. And there's your flare profile over the past 3 days. Again, don't be surprised to see an X-class flare and additional coronal mass ejections. Proton flux calming down here. We did see a minor spike yesterday also after this series of solar flares. Relativistic particles making it to Earth. Now we're going to do a cosmic ray rundown. You can see at the Opacity neutron monitor a significant downtick in cosmic ray flux over the past 30 days. Barentsburg, also a significant downtick. Let's go farther south to Athens, Greece. And only a minor downtick there at Athens, Greece. Relatively flat levels at the Athens neutron monitor. Going farther south to Mexico City to see a more precipitous downtick, similar to the one seen at Opacity and Barentsburg. Let's go back north to Oulu, Finland. And there's the 30-day chart from Oulu. You can see a significant downtick at Oulu. Remember, folks, cosmic ray flux is inversely proportional to sunspot number and the radio flux. Gold members of the SMASH team may have a little more insight into this than those of you who aren't. More on that in a moment. Let's look at the Antarctican monitors as they're looking pretty weird. Looking at DOMB, we see an uptick in cosmic ray flux. So going as far south as we can get to Antarctica, and there's DOMC, a slight downtick at DOMC. So a little bit of abnormalities happening there in cosmic ray flux on a global scale. For the most part, a downtick in cosmic ray flux, which is what you would expect seeing such an uptick in solar activity. Once again, thanks to our Twitch followers. We've got some new followers over there on Twitch. Thanks to everybody who tuned in. And if you're only viewing on YouTube, make sure you install the Twitch app and subscribe to us over on Twitch. It'll actually alert you when we go live, unlike some less fortunate live streaming platforms. Press like and subscribe if you enjoy the content on YouTube. Make sure you check our playlists. There are some videos that aren't about space weather. Also check the Smash Team site. If you haven't checked it out, smashomash.com/SmashTeam. If you're not seeing all of our videos appear in your YouTube feed, click posts at smashomash.com/SmashTeam. You'll see all of our major video releases right there. Today's featured product is Mensa. Make Earth not suck again. It's up to you. Make Earth not suck again. If you think that's a political slogan, you don't know me at all. I'm completely apolitical. I'm a pragmatist. I'm completely uninterested in politics. I'm only interested in things that work. So make Earth not suck again. It's up to you. This public service message brought to you at massive personal risk and expense by Smash staff and I. So help support the channel with some merch. Start a conversation. Tell your friends and foes about us. And don't forget to enter the promo code iCandy to save 20% on checkout through July 14th. Make Earth not suck again. It's up to you. And that's not a political slogan. That's facts. You can find links on our homepage as well as below this video at smashomash.com. Welcome to the Neo-Renaissance. We're propagating facts and trying to advance the science. Thanks everybody who's helped us do so over the last 5+ years of covering space weather on the daily. If you're into looking for solar flares, 94 angstroms is one of the better wavelengths to view them. You can see some flaring coming out of this sunspot. Again, likelihood of major flares is about as high as it ever gets. We're at a very high level of solar activity. Don't be surprised to see M or X class flares in the coming days. Winding things down, we've got a star chart for you. Usually interested in what's going on above my head. Venus reaching its apex across the ecliptic, as it and Mercury right near the sun. That's our star chart for Lehigh Valley, Pennsylvania. And we'll do a solar system forecast. We're only a couple of days from a full moon here. Let's show the 1 week forecast as Mercury speeds away to lap Earth once again. There's where things will be in a week. We will have a gibbous waning moon on the 19th. Next, some coronagraphs. And there indeed was a coronal mass ejection yesterday. It will be missing Earth to the west. So you'll see this propagate out here. Great imagery there from the Soho-Lasco C2. And we'll also show today's imagery. There's today. We'll show a little bit more of a breakdown here. So here is the imagery from the Stereo A coronagraph and the Soho-Lasco C3. And we've paused this here as we've caught that coronal mass ejection. There it is on Stereo A. By the way, this is Mercury on the imagery. Mercury right there. And again, that CME is off to Earth's west. No halo associated with that coronal mass ejection. We'll let it play through and show you some more imagery of El Sol. Don't worry, folks, the sun's not going to kill you. Terrible decisions by human beings might kill you, but the sun's just not going to do it. It might shut down radio transmissions. It might cause power grid failures. Who knows? But it's not going to kill you. Now, look at the filaments. This is the most filamentary material we've ever seen on the channel. Look at the size of this filament down here. Look at the instability of this filament up here. That is a lot of material in between Earth and Sun. And a bunch of that could be headed our way at any moment. That's the hydrogen alpha imagery from El Teide, Spain's ground-based solar observatory, part of the National Sunspot Observatory. Next, the GO 16 SUVI. Everything's still chilling for the past about 2.5 hours. Filaments still holding, and keep in mind those could collapse, but the likelihood they'll all collapse is very, very low. Some of those are likely to be blasted out as CMEs, or coronal mass ejections, in the coming days. So this is where we'll close things out, and thanks to our YouTube viewers. .171 angstroms is the house favorite wavelength. We'll see you soon with some more content, and in the meantime, may that solar wind be at your back.